Okay. Now these are the microstructures of the steels. Now in this first two diagrams, these are for what you can say that low carbon steels. Okay, these are low carbon steels. Here in bracket, I have mentioned that carbon is present at very less amount, 0.05%. Now, whenever carbon percentage is very less, its microstructure will appear like this. More bright spots will be there, and some dark spots are there. Some dark phases are there. Okay, whichever bright phases are there, it will be ferrite or your alpha phase. Bright phase is alpha phase, and some dark spots are there. These dark spots of perlite. Okay, perlite is nothing but a mixture of ferrite and cementite, but it will appear in the dark color. This is a perlite. And whenever percentage of carbon is less, ferrite percentage will be more. Okay, for example, this dead mild steel, it is having very less carbon percentage, 0.05%. Then the ferrite is almost more than 95%, and 3 to 5% only perlite. And as carbon percentage increases, suppose carbon is 0.1 or 0.2, then ferrite will be 75 and 25% will be perlite. That is the dark phase. Now we will suppose we move towards the medium carbon steel. In that medium carbon steel, carbon will be in the range 0.3 to 0.6. At that time, what will happen? Ferrite will be 50% and perlite will be 50% for medium carbon steel. Low carbon steel, whenever low carbon steel is there, ferrite amount is more, and perlite is maximum 25%, and remaining will be ferrite only. In medium carbon steel, 50% ferrite, that is the bright phase, and 50% perlite, that you can show by the dark phase. Same structure you have to draw, just you have to increase this dark portion. Then you can say that 50% is perlite and 75 and 50% is the ferrite in the medium carbon steel. For low carbon steel, ferrite will be more, that is bright phase will be more. And if carbon percentage is very nearer to the 0.008%, then ferrite amount is 95 to 100%. In that range you can vary. These are approximate values. Okay, it is 90, but it should be at the higher ranges. In low carbon steel, ferrite will be more and perlite will be in very small quantity. As carbon percentage is increasing, ferrite quantity will goes on decreasing and perlite quantity will goes on increasing. Then for medium carbon steel means 0.3 to 0.6% carbon is there. Ferrite and perlite 50% will be there. Then in the high carbon steel, in the above 0.6%, at 0.8% carbon, at 0.8% carbon, only one phase will be there, that is perlite. As carbon percentage is increasing and it is moving towards 0.8, ferrite will goes on decreasing and perlite will goes on increasing. And at 0.8% carbon percentage for this high carbon steel, 100% perlite will be there. And if carbon percentage is 0.008, 100% ferrite will be there. At higher range, 100% perlite, that is 0.8%. And for 0.008%, 0.008%, there will be only ferrite, only bright phase, just the bright phase will be there. Now in between this, somewhat point below this 0.7, you can say that only 5 to 10% ferrite, and dark phase will be there up to 90 to 95%. And when carbon goes above this 0.8, above this 0.8, now 100% perlite is there in the 0.8. When above this 0.8 carbon percentage is there, some amount of cementite will be formed. Suppose 0.9% carbon is there, then perlite phase is there, this dark phase, and bright phase will appear, that is the cementite for 0.9% carbon. exactly for 0.8%, 100% perlite is there. Okay, 100% perlite is there. And for medium carbon steel, 50-50% perlite and ferrite is there. And above this 0.8, whichever carbon percentage is there, perlite and cementite will be there. Amount of perlite will be more and amount of cementite will be lesser. For example, 0.9% carbon steel, that is high carbon steel. Dark phase perlite is there, which is present at approximately 90%, and 10% will be cementite. So this is the microstructure related to the low carbon steel, medium carbon steel, and high carbon steel. For medium carbon steel, 50-50% ferrite bright phase and 50% perlite dark phase. When carbon percentage is less for low carbon steel, try to remember this structure only. If carbon percentage is very less, just increase the amount of ferrite and decrease the amount of perlite. And when carbon percentage is at the higher ranges, increase the perlite. And at 0.8% carbon, 100% perlite will be there. You have to remember this: 0.8% carbon, 100% perlite. And for lesser values, that is 0.008, 100% ferrite will be there. And in between that values, you have to, according to this percentage, you have to write ferrite, perlite, then more percentage will be there, then perlite and cementite. Why? For high carbon steels. Okay. Then for tool steels, this is the tool steel. In this tool steel, perlite will be there. Perlite will be there. That will be a dark phase, and some bright spots will appear there, and that will be their respective carbide. It may be for any type of the tool steel. Perlite phase will be there. In that perlite, dark phase will be there as a perlite, and in that some bright spots will be there, and that bright spots will be of carbide. It may be chromium carbide, or it may be another carbides which are formed by another vanadium, molybdenum, whichever alloying elements you have added in that tool steel. Depending on that, carbides will be there. Sometimes they may ask you the microstructure of tool steel. Just you have to draw one circle in that dark phase perlite, and some spots you have to show, bright spots, and that will be termed as the alloy carbides bright spots. Okay, bright spots are there. So this is the microstructure of the plain carbon steel and alloy steel. In that we have discussed about the microstructure of low carbon steels, which consists of bright phase ferrite and dark phase perlite. When carbon percentage is lower, amount of ferrite will be on the higher side. For example, 0.1% or 0.2% carbon, 75% ferrite and 25% perlite. When carbon is very less, then 90, above 95% ferrite will be there, and perlite will be 3 to 5% only. Then when carbon percentage is on the higher side, perlite amount will be more. That 0.8% carbon, 100% perlite is there. And when it goes, carbon percentage goes above 0.8, perlite plus cementite will be there. Perlite plus cementite. And in medium carbon steel, means within the range 0.3 to zero point 0.6, just you have to draw the same structure, and 50-50% ferrite and perlite you have to show there. So this is the microstructure of uh, low carbon, low carbon, medium carbon, and high carbon steels. And along with this tool steels, in the tool steel, dark phase perlite and bright phase of respective carbides will be there. Okay, in this way we have discussed the microstructures of the plain carbon steels, alloy steels, and microstructures of the cast irons, different types of the